Hello, in today's lesson, we are going to be adding and subtracting rational expressions. So you can see a couple examples here of rational expressions with like denominators. But before I continue and talk about adding and subtracting rational expressions, I want to go back to basic fractions. So when you first learned how to um, add or subtract fractions, you learned that you have to um, get a common denominator. So if the denominators are the same, it makes it very easy. But if they are not, then you have to manipulate the fraction a little bit to get the common denominator. So in this example, you have 2 and over 3 and 7/8, and they do not have a common denominator. So one of the biggest struggles you're going to have with rational expressions is finding that common denominator. So I'm going to go through a couple of these examples first to show you how to find a common denominator with these basic numbers before I show you how to do that with rational expressions. So your denominator in the first fraction is 3. The denominator in the second fraction is 8. So if you look at these two numbers, they do not have any common factors. So what I mean is if you did factor 8 into its prime factors, it would factor into 2 times 2 times 2. So those, and if you and 3 is a prime number, so that wouldn't be factored any further. So if you notice, neither one of the denominators have any common factors. So when that is true, that means that you're going to have to multiply the first fraction by the other denominator. So you're going to be basically multiplying by 8 over 8, which essentially is the value of 1. So you're multiplying by that 8 over 8, or 8/8 times 2/3. And then the second fraction, since it already has a denominator of 8, you want to multiply it by 3/3. So again, we're multiplying each fraction by something that has a value of 1. So it's not going to really change the value of this fraction. It's just going to change the way it looks. So now if I multiply my numerators together, I would get 16 over 24. And then if I multiply my numerators together here, I would get 21 over 24. Now that they have the same denominator, when you add them, you will also have the same denominator. So that denominator does not change, but you simply add the numerators. So if you add 16 and 21 together, you're going to get 40 or 37. So at this point, you would ask yourself now, can you reduce this fraction, 37 over 24? Or do either one of these numbers have a common factor? In this case, the answer would be no, because 37 is a prime number. So we are done adding this fraction. Okay, but in this next example, I want to show you, I'm going to actually put a variable in there, and I'm going to have a minus sign. But you do not want to always simply multiply the denominators together to get your common denominator. In many cases, that is true because the denominators do not have any common factors. But if you look at 12 and 15, the factors or the prime factors of 12 would be 2, let me use a different color, would be 2 times 2 times 3. So those are the prime factors of 12. The prime factors of 15 are 3 and 5. So both of them already have a common factor of 3. But what's missing from the 12 is the 5. What's missing from the 15 is the 2 times 2. So The first fraction, 5 plus x over 12, we only have to multiply it by 5 over 5. So again, we're multiplying it by a value that's equivalent to 1, so that we're not changing the value of the fraction, we're just changing the way it looks, so that we can get a common denominator. And the reason why we had to multiply by 5 is so that we would get that common denominator. So again, if you look at your factors, you've already got a 2, 2, and a 3, so you're just missing the 5. In the second fraction, since you already have a 3 and a 5, you basically want to multiply by 4, because 4 is the equivalent to 2 times 2. So we're basically multiplying the fraction 4/4 to the numerator and denominator so that we can again get a common denominator. Now be careful with this first fraction when you are multiplying the 5/5 by the 5 plus x, you must distribute the 5 to both terms in that numerator. So the numerator now will be 25 plus 5x over 60. So the 5 times 12 gives us 60. In the next fraction, we just have a single number. So 4 times 7 in the numerator will be 28. And then 15 times 4 in the denominator would be 60. And now that we have a common denominator, we can combine the numerators. So 25 plus 5x minus 28 all over 60. So we can now combine our like terms, and we would get 5x minus 3 over 60. And that numerator cannot be factored, so we cannot reduce with the denominator. So this would be your simplified expression. But as you notice, if I were to multiply 12 times 15, I would get a much bigger number than just 60. So you do not want to just multiply each numerator by the opposite denominator all the time. You only do that when the denominators do not have any common factors. Okay, so now we're going to actually go back to the Algebra 2 level problem. So this is lesson 6.4 in your textbook. And we're going to start out with things that have a common denominator. So if you look at this first example A, there is a common denominator. So when you have a common denominator, you simply add the numerators. So 4x, so the first numerator is 4x, the second numerator is x, and your denominator now is, you only have to write this as a single fraction, 3x minus 5. We do have like terms in the numerator. 4x plus 1x is 5x over 3x minus 5. You cannot factor this denominator, so there's nothing we can reduce. So this would be our simplified rational expression. Now, we do want to also remember that we have to state our domain or undefined values. So if we look at the denominators that we started with and what we ended with, we have a 3x minus 5. So we have to ask ourselves what value of x would make the denominator 0. So that value would be 5/3. Since 5/3 would make the denominator 0, which would make the whole fraction undefined, we have to state that x cannot equal 5/3 in that expression. Okay, so the next one here, we now have a minus sign. Again, we have a common denominator. So if I just simply subtract across and rewrite this as one fraction, 14x minus 2x squared, all over x minus 7. So right now, if you look at your numerator, you do have a common factor here between the 14x and the 2x squared. So you would want to um, factor that out if it can be reduced with the denominator. And I'm going to show you that this actually can be reduced with the denominator. But there's a couple more steps that we're going to have to do. So the 14x and the 2x squared have a common factor of 2x. So if I factor out a 2x from each term, I will still have 7 minus x. In my denominator, I have x minus 7. So some of you are probably thinking, well, those are the same factor. Well, they actually are not. Because if you think about it, is 5 minus 2 the same as 2 minus 5? Well, no. 5 minus 2 equals 3. 2 minus 5 equals negative 3. So what's different is that they are the same number, but opposite signs. So one thing that you want to learn how to do is when you do have a binomial like this, where they're in the wrong order, you can factor out a negative 1. So if I take, let me just use a different color here. So if I take this binomial, 7 minus x, and I rewrite it in standard form, I would put the negative x in front plus 7. So you can see that the 7 and the negative x have really not changed. I've just put them in a different order. At this point, I would then factor out a negative 1. So if I factor out a negative 1, both signs are going to change. So the x becomes positive and the 7 becomes negative. So now that negative 1 would have to be multiplied with the 2x that's already out in the front. So let me change it back to my purple. So the negative 1 times the 2x would make this negative 2x. But now I have x minus 7, which will match the x minus 7 in the denominator. So now we have a common factor in the numerator and denominator. So it can be reduced. So our simplified algebraic expression is just negative 2x. However, we have to state what can x not equal. So in your original fractions, you have x minus 7. So we have to state that x cannot equal 7. So this is your undefined value, and this is your simplified expression. Okay, so before we get to adding and subtracting fractions that do not have common denominators, we're going to practice finding the least common multiple, which is also going to be called the least common denominator when we start adding and subtracting these fractions. But the least common multiple and least common denominator, it's basically the same thing. But we're going to look at these expressions that we have here and try to find the least common denominator. So starting with each polynomial, you want to factor this down into its prime factors. So the 9x to the third, 9 is factored into 3 times 3. X to the third is x times x times x. So if you multiply that all back together, you would get 9x to the third. So these are the prime factors of 9x to the third. If you look at the second polynomial here, we have two terms. Both terms can be factored, have a factor of 3 and x. So we would factor out a 3 and an x, and then we'd also have an x minus 7 in parentheses. Okay, so your least common multiple has to include factors, or it has to be made up of all of the factors of each one of these. But anything that they have in common does not need to be duplicated. So if we start with the 9x to the third, so your least common multiple has to have a 3 times x times x times x. However, your second polynomial here already has a 3 and an x out front. Well, the least common multiple down here already has a 3 and an x. So that's already part of the least common multiple, which means we do not need to duplicate it. But what's missing from the least common multiple is the x minus 7. So now, if you look at the factors of the least common multiple, it does include all of the factors of the first term, 9x to the third, and the factors of the second term. It's got a 3, an x, and an x minus 7. So your least common multiple then, which eventually we're going to call our least common denominator, will be 9x to the third times x minus 7. Okay, so now let's go on to example B. So in example B, we have two trinomials. If I factor the first trinomial, I will get x plus 2 and x plus 3. If I factor the second trinomial, I will get x minus 6 and x plus 3. So your least common multiple has to include the factors of each of these. So it has to have an x plus 2 because this has a factor of x plus 2. It also has to have a factor of x plus 3 because the original has a factor of x plus 3. Well, the second trinomial already has a factor of x plus 3, and the least common multiple already has a factor of x plus 3. So they have that factor in common, which means you do not need to duplicate it. But what's missing from the least common multiple is the x minus 6. So now if you look at your least common multiple, it has both factors of the first trinomial, but it also has both factors of the second trinomial. So your least, and you do not want to multiply this back together. You want to leave your denominators in factored form. So this is your least common multiple. All right, we'll do one more example, and then we'll start adding and subtracting things with that are not like terms. Okay, so the first binomial here in example C cannot be factored, but the second one can be. We'll have to use our AC method. So you will use all of your factoring skills for this lesson. So the 2x squared will stay the same. The plus 5 stays the same. If I multiply my a times c, I get positive 10. And my two numbers then that go in the middle will be positive 1x and positive 10x. Or you could have it the other way around. Then we factor by grouping. We can factor out x, which leaves us with 2x plus 1. Factor out a 5, a positive 5, which again gives us 2x plus 1. And then factor out the 2x plus 1. And then we have the x plus 5. All right, so these are the factors. So these are the factors of this trinomial. The first expression, though, is already factored. So the only factor is itself. It's a linear factor. So a linear factor is like a prime number. So now when we create our least common multiple, it has to have an x plus 5, but it does not need to have more than one because this trinomial only has one factor of x plus 5. But what it does need besides the x plus 5 is a 2x plus 1. So your least common multiple sometimes is one of the polynomials that you're given. Okay, so how are we going to apply that? So now we're adding and subtracting things that do not have or with unlike denominators. So my recommendation is factor all the denominators if you can or if necessary, and state the undefined values. So factor all your denominators if necessary or possible, and state your undefined values. Before you start reducing anything, I would recommend that you state your undefined values right away. Then find your least common denominator, which again is your least common multiple, same thing. And then multiply each fraction by the missing factors in its denominator. Then we combine and simplify the numerator. And then, if possible, we can simplify the rational expression that we get after step 3. So you have to do step 3 before you can do step 4. Okay, so here we go. If we look at our first problem here, x minus 2 cannot be factored. X plus 8 cannot be factored. They are both linear factors already, so they're both already prime numbers, so to speak. They do not have any common factors, which means your least common denominator will consist of both the x minus 2 and the x plus 8. So if we could look at this first fraction, it already has a denominator of x minus 2. So in order to make it match this least common denominator, we have to multiply both the numerator and the denominator by an x plus 8. Again, x plus 8 divided by x plus 8 has a value of 1. So we're not really changing the value of our fraction. We're just going to change the way it looks. So now when I distribute that 15, my new fraction will be 15x plus 120. All right, now let's look at the second fraction. So the second fraction you have is 3 over x plus 8. So it already has a denominator of x plus 8. So it's missing the factor of x minus 2. So you do have to multiply both the numerator and denominator by x minus 2 so that you will get a common denominator. The 3 has to be distributed. But you can leave your denominators in factored form. So it doesn't matter that we have x minus 2 first and x plus 8 after it. When you're multiplying, the commutative property says it doesn't matter which order you're multiplying them in. So these are the same denominator. Now that we have a common denominator, we can start adding our numerators together. So since we're adding, look for like terms, combine them. So the 15x plus 3x is 18x. And then your 120 minus 6 is a positive 114. Your denominator is still x minus 2 and x plus 8, or other way around is fine also. Okay, so at this point, we have to ask ourselves, can we simplify this fraction anymore? Oh, and the undefined values, we forgot to state those. So x cannot equal 2 and x cannot equal negative 8. So those would be your undefined values because we cannot have a denominator of 0. All right, so going back to the question, can we simplify this fraction? Well, if I look at 18 and 114, I could possibly factor out a 2. I don't think actually a 3 could be factored out also. So actually 6 could be factored out of both of them. So if I factor out a 6 from both terms, I would have 3x plus, let's see, it goes into 11 once, 19. So we'd have 3x plus 19. However, will either one of these factors in the numerator reduce with either one of the factors in the denominator? Well, no, because they're not the same. A binomial factor has to be exactly the same as another binomial factor in order to be able to be reduced. So you do not have to factor the numerator if you cannot reduce it with the denominator. So basically what I'm saying is that this answer is perfectly acceptable. You do not have to factor the numerator, or if you do, that's fine, but it can't be reduced with your denominator. So either one of these are acceptable answers. Okay, hopefully that made sense. Going on to the next example. So the next example, like I said, like this one, it's going to get bigger before it gets smaller. We'll use purple. So if we look at our first two denominators, they cannot be factored. So your least common denominator is going to have a factor of x minus 7 and x plus 1. The third denominator can be factored. So if I factor x squared minus 6x minus 7, it does give me the factors of x minus 7 and x plus 1, which are the same as these two. So your least common denominator will be x minus 7 times x plus 1. So now, break down each fraction and ask yourself, what do I have to multiply each fraction by? So the first fraction already has x minus 7 in the denominator. So we are going to multiply the numerator and denominator of the first fraction by x plus 1. Then we have a minus sign here. And I'm going to simplify this in a minute, but I'm just going to keep going here. 2 over x plus 1 is what we originally started with. And we are going to multiply both of the numerator and denominator by x minus 7. Because this denominator already has an x plus 1, we need to multiply the top and the bottom by x minus 7 so that our denominators will match, so they're the same. All right, our third fraction, we have 8x over, and I'm going to leave this in factored form, x minus 7 and x plus 1. Well, since this third fraction already has both factors of the least common denominator in it, you don't have to multiply the third fraction by anything at all. It's just going to stay the same. All right, so now that we have a common denominator, we need to focus on the numerators. So your x needs to be distributed, which will lead us to give us x squared plus 1x. Now, when you have a minus sign, when you're subtracting, you need to be very careful. I like to, especially if there's just one term, I would put there's a different color here. I would put the minus sign in front of the 2 and change that to a plus. So I'm really technically distributing negative 2 to both terms, which will give me negative 2x plus 14. And then the orange. The third fraction, you do not need to multiply by anything, so it's just going to be minus 8x. Now your denominator, we can make this one fraction now since our denominator was the same all the way across, x minus 7, x plus 1. All right, so now we have to combine the like terms in our numerators. So we have only one x squared term. The 1x minus 2x, that's negative 1, minus 8 is negative 9x. And then my constant is 14. And that's all over x minus 7 and x plus 1. So just like the last problem, you don't have to factor the numerator unless it can be reduced with the denominator. So if you look at this trinomial, ask yourself, can it be factored? And if it can be factored, will it be reducible with does it have a common factor of your denominator? And before I start crossing anything out, let's state our undefined values. So our denominator has an x minus 7, which means x cannot equal positive 7. If you have a factor of x plus 1, x cannot equal negative 1. So these are your undefined values, or your domain. You would say your domain is all real numbers except when x equals 7 or x equals negative 1. So that's another way of writing the domain or your undefined values. Okay, so hopefully back over here, if you were looking at this trinomial, you noticed this can be factored. So your numerator can be factored into x minus 7 times x minus 2. And our denominator also has a factor of x minus 7. So the common denominator or the common factor can be reduced, leaving us then with a simplified value of x minus 2 over x plus 1. So that's our simplified rational expression. Okay, let's see, what else do I have here? Oh, so I got a couple more, maybe a little bit harder. Okay, so example C. Again, I would want to factor my denominators first. So if I look at this denominator, I can factor it into x minus 2 and x minus 1. My denominator in the second fraction, I can factor out a 2, which then leaves me with x minus 2 in parentheses. So when I'm creating my least common denominator, I have to have an x minus 2. I also have to have a factor of x minus 1. But I also have to have a factor of 2. And since that's a monomial, I'm going to put it out front. So the x minus 2 and x minus 1 are in the first fraction, and the 2 and the x minus 2 we have also present in our least common denominator from our second fraction. So this is your least common denominator. At this time, I will also state my undefined values. So since I have a factor of x minus 2, x cannot equal 2. Since I have a factor of x minus 1, x cannot equal 1. All right, so I'm done with my least common denominator, finding my least common denominator and my undefined values. So now we need to make our fractions, we need to get a common denominator. So our first fraction has a 5x minus 1 in the numerator, and the factor denominator is x minus 2 and x minus 1. So the least common denominator, so we need to multiply, so the factor that we're missing is 2. So we have to multiply, and since it's a monomial, I'm going to put it in front. I have to multiply the 5x minus 1 by 2. And I'm going to put the 2 in front there to match. So now that matches my least common denominator. The next thing I would also recommend is that you distribute this negative. So since you're subtracting, that's going to change both of those signs. And once we distribute the negative, we can then add. So the negative 2x will become positive 2x. The negative 1 will become positive 1. If we look at our denominator, you already have a 2 and an x minus 2 in this denominator. So if you ask yourself, well, what's missing? The x minus 1. So we're going to multiply this fraction by x minus 1 in the numerator and x minus 1 in the denominator. So now if you look at both denominators, they are the same. They both have a factor of 2. They both have a factor of x minus 2. They both have a factor of x minus 1. All right, so now we have to simplify the numerators. And we can make this all one fraction now with our denominator of 2x minus 2, x minus 1. Distribute the 2. So I'll get 2x minus 2 there. But in this next one, we have a binomial times a binomial. So you're going to have to distribute the 2x to the x, which will be positive 2x squared. The 2x to the negative 1, that's going to be negative 2x. 1 times x is a positive 1x. And then 1 times negative 1 is a negative 1. Combine your like terms now. So if we look at our like terms, we have a 2x squared. Then you have a 10x minus 2x, that's negative 8, plus 1 is positive 9. And then you've got negative 2 minus 1, which is negative 3. In the denominator, we still have that 2x minus 2 and x minus 1. So once again, we now need to ask ourselves, can we reduce this anymore? Basically, looking at your numerator, can you factor this trinomial? And if you could, would it have the same denominator as, or would it have any common factors with the denominator? So if I look at my numerator, I would have to factor this with AC method, but my A times my C would be negative 6. So that'd be my AC. Are there two numbers that multiply together to equal 6 that have a difference of 9? No. So this cannot be factored, which means that we are done. This is our simplified rational expression, and these are the undefined values. All right, one more example. Okay, so again, you want to factor this denominator. It's going to factor into x minus 6 and x plus 3. The second denominator already has the x minus 6. So your least common denominator will be the product of x minus 6 and x plus 3. So this first fraction already has both factors in that denominator. So the first fraction does not need to change, but you do want to leave your denominator in factored form. I'm going to, right now, just bring down the minus sign, because this is the type of problem that a lot of students miss because you're subtracting a binomial here. So I'm going to give you a couple different ways of simplifying it. All right, so the x minus 6 is already in the denominator. And then we also have this x plus 2 in the numerator. So what's missing from this fraction is the x plus 3. So we are going to have to multiply both the numerator and denominator by x plus 3. So you could distribute the negative to the x plus 2 first, or you could multiply the binomials together, then distribute the negative. And personally, I think that that is the better option. So that's what I am going to do. So now that we have a common denominator, I'm also going to make this one fraction, x minus 6, x plus 3. My numerator here is 2x squared, but then I'm going to be subtracting. And maybe I'll do this over here. So the x times the x would be x squared. X times 3 would be positive 3x. 2 times x is a positive 2x. And 2 times 3 is a positive 6. So I'm actually subtracting x squared plus 5x plus 6. So when I subtract, that's going to change all of my signs. So when I distribute that negative, everything's going to change. So the 2x squared is still up front, but then I'll have a negative x squared, a minus 5x, and a minus 6. X minus 6 and x plus 3 are still the factors in your denominator. Now when I combine my like terms, the 2x squared minus x squared is just 1x squared minus 5x minus 6 all over x minus 6 times x plus 3. All right, so now that we've got everything simplified in one fraction, you have to ask yourself, can I reduce this at all? So if you look at your numerator, can it be factored? And if it's factorable, can it be reduced with one of these denominators? Oh, and I forgot my undefined values. So just state them over here. X cannot equal 6 and x cannot equal negative 3 because that would make the denominator 0. If I look at this numerator, I can factor that into x minus 6 and x plus 1. So this numerator is factored into x minus 6 over x plus 1. The denominator is still x minus 6 and x plus 3. So now you can see the factor of x minus 6 can be reduced. And our simplified rational expression is x plus 1 over x plus 3. Okay, so that ends our lesson for today. I know that's a long one. We are not going to be doing complex fractions this trimester, but if you are interested in learning about complex fractions, which you will use in both pre-calculus and calculus, send me a message and I will try to make another video explaining the complex fractions and giving you some practice using those or simplifying them.